So we have Giovanni here. He's a professor of architecture at UC Berkeley, and a lot of his work is focusing on using environmental performance as a driver for architectural design. And I'll just let Giovanni get started from here and add the
Okay,
introduction.
thanks a lot as well for the troubleshooting. Can you just tell me that everybody can see my presentation on the screen? Can you see the presentation?
Looks good on my
Looks
end.
good. Good. Brilliant. That's always comforting. Okay, so we have overcome this little technical hurdle, and now we're good to go. So thanks everybody for joining in and listening to this presentation. So I allegedly the topic of the presentation is about this tool that I have been developing with some colleagues over the past few months for online and open source climate analysis for the AEC industry. I thought just before that to give a little presentation about myself, what my background is, so that we get to know each other a little bit. So as Christine just said, I'm currently assistant professor of architecture at UC Berkeley, and in there I'm part of the CBE Center for the Built Environment, which is a research group that has over 20 years of history, really in exploring topics that relate to thermal comfort, human well-being inside the built environment, and low energy buildings. My background is actually, funnily enough, not really that of an academic, but I've been involved so I've been a practicing architect working in various research teams around Europe. So I spent about 8 years at Foster and Partner in London, where I was um, associate partner in the specialist modeling group, which was this fantastic interdisciplinary team that really got the chance and the privilege on working on all sorts of crazy integrated projects, from building a zero carbon pedestrian friendly city in the middle of the Abu Dhabi desert, to projects like the spaceship Apple campus, which is and Bloomberg headquarters in London, which are massive commercial projects, but also that really push forward notions about sustainability and comfort inside office buildings. Both of those are naturally ventilated buildings, despite they're just their humongous size for the majority of the year. And we were doing all sorts of things, plotting about moon bases, and that should have been 3D printed by robots and whatnot. And I think that what links that work to many of the topics that Speckle as well deals with is this idea of really multiple disciplines that come together on a building design. This is just a diagram that we did back in the days about the National Bank of Kuwait that has just been completed, and high-rise in Kuwait City, and really, like, you see all the different disciplines from architecture, of course, but then structural integration, CFD, construction aspects, understanding solar radiation, of course, understanding the thermal aspects, understanding buildability issues, understanding acoustics. So we've been spending quite a bit of time really wrestling how all our digital tools could speak with one another. And then the past 5 years, between 2015 and 2020, um, 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 I mean, we all know that 2020 never happened because of the pandemic. So um, um, I was actually in Berlin in an architectural office called the Hen Architects, where I sort of set up and led a team called performance-based design performance-based design, where essentially we were taking those concepts and working even more closely with the architectural department, and really trying to have all those those computational tools that help to evaluate performance really to be merged in the design process even more. And as part of this 5 years at Hen, I was lucky enough to be involved in a number of research projects. So that's where I guess the affinity with academia came by, and the desire to be more involved. And one of those projects, you might have heard it mentioned by Dmitry earlier on, was this InnoChain project, which was a really fantastic model of collaboration, where we were partnered with Bartlett, the School of Architecture, but it was really a who's who of the most interesting both architectural engineering offices in Europe, and also architecture school. So there was CETA from Copenhagen, ITKE from Achim Menges, and all those fantastic work that happens there. Um, and the EAC in Barcelona, and we also had our Foster, Hen was there, BIG, and so on. So and also we had Rhino and a few other players. So it was really a fantastic team, and we were taking part in this as sort of industry partner. What was really fascinating about this collaboration was the fact that essentially there were 15 PhD positions that were funded. And those PhD positions were revolving around questions that industry partners were writing. So this is a bit a tangent from the main topic of the conference, but I really I thought it's interesting because it tells about my relationship with Speckle, because essentially we put out this quest for a PhD candidate that would help us to explore alternate means to communicate measures. How do you share all of those results in an architectural environment? How do you enable smoother data flows between all those different specialist applications? And lo and behold, our Dmitry was the winning candidate for that application. So I had the pleasure of working with Dmitry for over 3 years when we were in Berlin, between Berlin and London, during his PhD. And that was so essentially I was going around the office explaining what he was doing while he was drinking beers, as you can clearly see from this picture. But jokes aside, it was a really great time of experimentation and really putting together the basis of what then became Speckle. And Dmitry was, and we were essentially, I was forcing our colleagues to be our guinea pigs with the very early versions of Speckle. How do we deploying the first servers, and trying to explain everybody how this could be used, and how this could work, and so on. And the rest is sort of history, and you're familiar with all the amazing things that Dmitry, and then now with Mateo, and then with a growing team that they've been developing. So I think I'm really happy to be here, and to see that this work is really evolving and expanding, and it's creating such a large and fantastic community. So this is really fascinating. I'm really happy about that. And that's enough for the down memory lane. So I'll go back to the topic of the talk, which is this little tool that we have developed, and it's open source and it's freely accessible. And it's really a very simple thing. So there is not much to say about it other than go to clima.cbe.berkeley.edu and you will have access to climate analysis on the cloud. Of course, there is a bit more to say about this. And first of all, I think we need to start with acknowledging that I'm here talking, but of course there is a team that has been working with me over the past 10 months. So it's a quite young and simple project in that respect. And especially, so Federico Tartarini has been developing the bulk of the web interface. Christine Nguyen has been helping me with the first experiments, and Stefano Schiavonda has been helping with getting the money and also coordinating all the effort and providing guidance along the way. So the main funding is from the Center for the Built Environment. So thanks for this to happen. And it's really a relatively simple thing. So Clima is essentially, it's an online open source tool. Is essentially a data dashboard that allows you to access and visualize climate data and to really look at those data with quite a good degree of flexibility. So, I mean, climate analysis and thinking about climate responsive architecture is really nothing new. And you can look throughout architectural history and find so many beautiful and sophisticated examples of how different culture with different material possibilities, with different technological means, have developed climate adapted architecture. So we can start from the wind tower of Yazd in modern day Iran, to the conical huts in Vairibo in modern day Indonesia, and we can look at how those are adapted to very different climate, the desert, and the strong amount of rain or city pattern in the Middle East. That provide shade and compact city, and how we can talk about this for a long time. But I think that what is interesting is that there has been, of course, a sort of cut in the way those things have been developed with the advent of modernist architecture, and essentially there has been a change in a seizure in the moment of this development of the traditional vernacular architecture through the revolution of the modern movement, and the way we would be looking at climate, and no longer through tradition, through knowledge that is handed over generation after generation, but more trying to figure out those universal solutions, exemplified here in some sketches from Le Corbusier. Sorry, the notes at the bottom is actually wrong. And this developed after the war, in the 40s and 50s, in a series of experiments, both in the States and in Europe, looking at really starting to apply early data-driven techniques and collecting data from weather station, and then trying to understand climate. I think this is from a beautiful real-life parametric experiment that was conducted in Norway for about 30 years, where essentially they were trying to understand what is the cheapest, most effective construction that we can use to keep our little houses warm during the punishing winter in Norway. So essentially, a professor at the Institute of Architecture in Trondheim, he started building a series of perfectly equal huts, just varying the construction of the wall, putting in a heat source. I think it was just essentially a light bulb, a thermal resistance, and measuring how the temperature would fluctuate inside those huts. And this is sort of real world parametric explorations, I guess, creating these very reproducible experiments and trying to measure which one was the construction that was at the same time the cheapest, best to build, and most effective at preserving the heat or reducing heat losses. And then this starting to look at climate as something that is universal and that can be applied across very different climatic locations, and that can be looked at through the lens of data, then very quickly started to evolve into the topic of climate analysis and data visualization, as we know it today. And I think this is one of the early charts that was produced essentially for architects. This was in an American Institute of Architects bulletin in 1950, a climate analysis of the Boston area, where you see those violin plots represent the probability distribution function of temperature for day and night for each month, so that you get the extrema, you get the most typical function, the typical temperature, and you get a sense also visually of the shift in temperature between night and day, and so on. So I think starting to have this sort of how do you communicate with architects and in general professionals in the architectural and engineering and construction industry, those abstract topics of climate, of weather pattern, and how do you make those reproducible. And I think I put those graphics here because in a way they are one of the earliest modern attempts at communicating those data in an engaging graphical way, and that is also specifically dictated for architects, and that is specifically targeted at architects. Sorry. Um, and I think they're still quite compelling to this day, and they've been a source of inspiration in the development of our own tool. And of course, we're not the first ones that look into climate analysis, and we don't even claim to be the best ones. But I think that there was a need at this moment. To me, was quite surprising looking around the landscape, and you either find tools that are quite specialist and relatively old, or also tools that I'm a big fan of the work of Ladybug, Mustafa, and Chris, and I think it's a fantastic work. But you have to understand that when something that it is so fundamental as climate analysis, that it's something that should be part, I believe, of every project, to access it, the best tools that we have today are sort of inside a plugin to a software. I think that it is a bit too complicated, and I think it certainly has its use, and it has a lot of advantages for people that really dive deep into those topics, that are into that and I've been a very happy user of their tools for many years, and I count to keep on being so. But I think that there is a possibility of creating tools that are just easier and probably offer wider distribution. And essentially, I'm hoping to be a gateway drug to people then being hooked on the topic of climate analysis and how do you drive architectural form and what decisions can you make about a building through an understanding of the climate, and so then help drive even more people to be interested in dive further and deeper with Ladybug and so on. So our tools, our goals, sorry, in the development of this tool were really quite simple. We wanted to have something that was really, really easy for everybody to access. That was really, really, really easy to use with little or no instruction or little prior knowledge. So it means also very easy to understand and flexible, so that it could be something for beginners, but also something for more experienced users that would want to get something done quickly and just answer on the fly a question that they might have about a specific location or a specific climate. So as I said, this is an open source tool, and it's all working on you're building on the shoulders of giants. So it's all built in Python. We do all our data processing mainly with pandas and NumPy. We use a couple of open source Python libraries for psychrometrics and solar geometry. And I need to give a special that are as well open source. And I need to give a shout out to Federico Tartarini and Stefano for the development of PyThermal Comfort, which is essentially a Python package that calculates pretty much any psychrometric quantity that you might think of. So that has been pretty helpful in the development of this. And then pvlib, which is a Python-based library, mainly geared towards photovoltaics system assessment, but it also had, in order to do that, it had all the equations for sun position, altitude, azimuth, zenith, you name it. So we decided to use this one. And then we are using, again, two other open source projects, Plotly for the creation of the graphs themselves, and Dash for the creation of the web app and for serving the web page that you can see. And in our app, our own little work, it's all under MIT license, which means take it, rip it, and clone it, put it inside your own web page, do whatever you want with it. We're just happy if people use it. Of course, we're happier if people contribute and help us to develop the project even further, but you're absolutely free to do whatever you want. And we also have a Creative Commons license for the graphics that are produced, which means you're also free to use them for profit or non-profit purposes. You're happy to change them, manipulate them. It's nice if you acknowledge that you've used this tool, but we're not going to chase anyone because of this. And we have launched a beta version of the tool at the end of August, and it has already been pretty minimal publicity that we've done, a couple of newsletters. I think probably the biggest vector so far are 3 LinkedIn posts, but we've been quite happy with the response so far. So we've seen that there are users worldwide, and we're clocking around 100 users a day, so which is pretty amazing for a tool that is relatively serving a niche. We also see that it's really a work tool because our user profile really drop over the weekend. So people use this to the work, which is what this meant to do. This also works on your phone and whatnot, but it's really thought as a desktop app because that's still where architectural work is being done. Yeah, and I was thinking we should probably try and do a live demo of the tool if that doesn't work, because Hopin is hogging too much broadband, or I can't share that. We might still revert to the slideshow. Now, it would be amazing if somebody could let me know that you're still seeing this. I think you are. I think I'm projecting my old screen, so that is good. So yeah, the address is clima.cbe.berkeley.edu, and when you launch the site, you're simply welcomed by a map. You have an option to drag and drop to select any EPW file that you might have on your computer if you have a file that you want to analyze that is not in this collection. This collection has two sources. One is climate.onebuilding.org, which is a fantastic effort to collect data worldwide, and the other one is Energy Plus and the Department of Energy of the US that have been collecting weather files. You can see that the darker dots are the Energy Plus data, and they are very US centric, and the lighter blue dots are climate.onebuilding.org, which are very much more distributed geographically, and they also are much more recent in terms of data collection. So we're thinking that potentially at some point we might drop the Energy Plus data, but those are those things that we welcome your feedback. So the navigation is pretty straightforward. You just go to the place where you want. So let's say that because I'm based in Berlin at the moment, I want to load a weather file on Berlin. So you just click there, you say, yes, please load the weather file. And it takes a moment, and hopefully it loads the weather file and doesn't embarrass me in front of this audience. Probably the APW has been successfully loaded, but it doesn't show. Okay, so let's restart this. And of course, did I mention this is a beta project? This is a beta version. So now we have loaded, and you might have noticed that all those tabs now got activated. So essentially, the idea is that you can use those tabs to sequentially, and there is a sort of rationale between this sequence. You start with a basic summary of the weather, temperature and humidity, sun and clouds, wind. Then it starts getting a bit more complex, a psychrometric chart, natural ventilation, outdoor comfort, and the last one is for the more hardcore users. Data Explorer lets you customize lets you look at all the data in very flexible ways. But essentially, you can just go through the tabs left to right. And this is letting me down. Okay, so as we were mentioning, so at the beginning we start with a climate summary. So we show a little bit of statistics. I think one thing that is very important is that we also give you a sense of when the data are because have been collected, because we all know that we are through a period of climate change. So some of those data are still relatively speaking historic data. And we're working towards making that clearer and also enabling people to do their choice on what type of data they want to use. So we're trying to do this very transparent. You can also use this first tab to download the Energy Plus weather file that you're just analyzing, or download our Clima data frame, which contains a lot more variable that are calculated. I'm going to show you those now. And then here we enable you to have a first analysis on, for instance, cooling and heating degree days. And you see here that's for Berlin, which is a heating dominated climate, so a lot more cooling. It's a lot more heating is required than cooling. And we have things like you can set, for instance, the set points for heating and cooling, so that you can sort of customize those to your building use and to the whatever purpose you have. Then moving, we have the temperature and humidity chart, where you can see temperature profile or humidity profile through this drop down. You can choose which one to display, and this one is showing the same data, but shown in 3 different ways. So you have first sort of the average temperature for each day, and then just the bars that give you the maximum and the minimum. That's kind of helpful to understand the range of temperatures over the whole year. And then here you have instead each day of each month. So you start at midnight, go through the morning, midday, and afternoon, and you can see the temperature profile, how it changes, and you have in solid line the typical day, and then as dots you can see the range of temperatures that are perceived. And this is kind of helpful to understand what are the daily ranges, and it's helpful to understand things like nighttime ventilation, feasibility, or thermal mass. And then here you have a heat map. So this is a calendar, sort of each point on the x-axis is a day of the year, on the vertical axis is an hour of the day. So here you have the whole typical year that is contained in those weather files that is displayed here. You can see also that's a cool feature of those interactive libraries that we are using, is that as soon as you hover with your mouse, you will have some feedback, so you can pinpoint what is the time of the day, what is the value there. And also all of those graphs are interactive and zoomable. So you can say if you're interested in between 8 a.m. to 8 p.m., you can simply do this and then double click, or using the home button on those graphs will bring you back. And as you can see as well, all those graphs, then, because we want to enable these in production, all those graphs are downloadable, so that you can straight away use them in your reports and presentations and to communicate with clients. So if you just click here, it will download them as vector graphics. So this is vector, which means can be printed at very high resolution without loss, can be open in Illustrator, can be put in your PowerPoint presentation, in your InDesign report, and straight away used. Same graphs we serve for relative humidity. There you go. And then we start going into some of the data that we use those other libraries for. So we show you a sun path. So those are all calculated data, are not really contained in the EPW, but you can generate a sun path from the location. Again, it can be downloaded. Everything can be downloaded that you see in Clima. And you can choose, for instance, to overlay any value that you have in the EPW, in the weather file on top of this. So if you want to know what is the, if you want to have an overlay of temperature on this sun path or solar radiation, that is pretty straightforward. We also offer two ways of displaying a solar path, sun path. This might change. So we have a spherical projection, which is essentially assuming that the sky dome is a half sphere and you look at it from the top in a plan view, as to say, or a Cartesian projection where you unwrap it as on a latitude longitude projection. And again, with all the hovers, and the hover are interactive, so if you load more data, you will have more information. If you have less data, you will have slightly less information. Then here we offer you global and diffuse horizontal solar radiation. So just to get a sense of how cloudy the weather is, what is the split between direct and diffuse. And this is a cloud coverage, blue meaning that's a clear sky, white it's an intermediate sky, and gray is cloudy. So you get a sense of how cloud coverage changes throughout the year. And then to help exploration, here we have a bunch of data that relate to the weather, that relate to sun and the luminous environment. So for instance, you can download plots for the illuminance, or diffuse, horizontal, whatever. This goes on, and I'm trying to go quickly, but I want to show you here. So here we generate a bunch of Windrowses. One thing that is pretty neat about Plotly is that, as I was saying, everything is interactive. Also, the legends offer some degree of interactivity. So maybe one thing that sometimes is interesting to know is where the strongest wind comes from. And you just can, sorry, I'm misclicking. So you can just select items on the legend, and it will sort of, with a double click, it will isolate that legend item. So here we can see that despite having that Windrows, those are the directions from which the strongest winds come from for this particular location. So which is not necessarily immediately apparent from the Windrows. So I think this is helpful in that way. And this hasn't loaded. Okay, this is going back to the bugs that we are still hunting. We also offer seasonal Windroses, so already pre-selected for you, summer, winter. And if they had loaded, which they haven't, which is a shame, we also offer daily Windroses. I think this is probably lots of you are clicking, and our poor server is being overwhelmed. So the daily Windroses, and also a fully customizable Windrows, so that you can say, if you're interested in knowing August between 8 a.m. and 8 p.m., you can as well do that. And again, if you're interested to know if there are strong winds that come in that period, you can still analyze that. And there are no strong winds for that particular Windrows. So I'm quickly going through the various tabs. Another one that may be interesting is the psychrometric chart. So here you can plot all the data points, you can sort them, you can look at the frequency of them. So what are the most frequent occurrences? You can color the points based on different data. You can filter them. So again, if you're interested just in summer, I don't know, and we're interested only in the central hours of the day, we can just select that, apply the filter, and we have that straight away being filtered out. We can look at the frequency, we can look at all the different whatever quantity we want as an overlay. on the chart. So I think that can be quite helpful. And we can also apply a filter based on actually specific values. So let me just expand this again to show the whole data. And if we want to if we are interested only at knowing when, for instance, the dew point temperature is above 18 degrees, and yeah, we're not interested at the lower terms. I'm just going to put -20. This will just sort out the data and show it to show a better example that it's easier to visualize. I'm interested, for instance, in the relative humidity that is between 50 and 90%. If apply the filter, you see that it has taken away all those other data. And again, we offer a pretty good data-rich overlay. Going on, we offer a natural ventilation assessment. So essentially, this is a relatively simple but quite effective assessment that it says, well, natural ventilation, I can do it between a minimum and a maximum temperature. And you can look at that. And typically you would use, for an office, you would use 10 to 24 degrees. Maybe for a residential, you would have a higher, lower temperature. But essentially this tells you, based on outdoor air temperature, what is the potential for natural ventilation. You can apply the same filters as before. You can say if you have a radiant system that might cause condensation, you can apply that filter as well. And again, more data points will be excluded. And you also get a nice bar chart that tells you month by month how often that is possible. And if you say, I want to have it actually only during the day, so I'm not interested at nighttime natural ventilation, I want to just do natural ventilation during the day, you can do that. The plot will be contoured and you have the results just for that. And then finally, the last thing that I'm going to touch upon very briefly is that we also offer UTCI scenarios. So UTCI is a sort of felt temperature for architects, which means how do you perceive, how a standard person perceives outdoor conditions under the influence of sun, wind, humidity, and sun, wind, humidity, solar air temperature, and air temperature, of course. Air temperature, mean radiant temperature, wind, and humidity. And of course, as architects, the two things that we can more easily control are sun and wind. We can't really change the outdoor air temperature. We can't really change, it's difficult to change the humidity content of the air in an outdoor space, but we can control if we are exposed to the sun and to the wind. So this kind of gives us an overlay, and you have 4 scenarios to choose, whether you're exposed to the sun and to the wind, to the sun but not to the wind, and you can see how the felt temperature change and how the corresponding thermal heat stress changes with it. So I'm going to quickly go back to the presentation for just some final words. And essentially, there are also, actually, no, going back to this, then a lot of those things I say that are, we wanted to make it easy for people to understand. So we're also working on an extensive document or a comprehensive documentation of the Clima tools that you can access from the website, where we essentially then are going to explain all the tabs. How do you select a weather file? What is in the climate summary? What things mean? We're gonna write an explanation for the degree days. This is still very much work in progress. Some parts are further ahead than other, but sun path. How do you read the sun path? What do they mean? What are the variables that you can show? How sun path changes with location. So hopefully this is going to be as well a resource for everybody that can as well become an educational resource. If you want to contribute, we're more than happy. There are various ways in which you can contribute by helping us further developing the code. And we have a GitHub repository on the Center for Built Environment, Clima. Then we have the Gitbook documentation, of which I've shown you briefly. And then you can also contact us. We have a form to report things, but also you can just write me directly an email. And then talking about next steps, well, the first big next step is that we want to get user feedback. So what the community judges to be useful aspects of the tool, and what are the missing bits to help you do your work more effectively. We're working on the documentation. We're working on various UI improvements and hunting bugs. And we're also working on incorporating as well future weather files, because we have to be cognizant of climate change and everything that goes with it. So we're looking at including in the interface the possibility of choosing future weather file under certain climate scenarios. So from me and my colleagues, thank you for bearing with me and for listening to this presentation. And I don't know, I've been a bit over time, but maybe we have time for some Q&A. I'm going now through the messages here. And yes, thanks for all the guys that have posted the links in there. I have tried to add some QR codes that are easier to scan with your phone during the presentation. But as I said, we're happy for you guys to join and contribute and give us your feedback. Okay, there are questions. Oh, there is a Q&A tab. Do you have plans to bring design analysis similar to Ladybug into this tool using Speckle? No, we do not have plans for that, because what we think is that we want to have. I think this is sort of we want to do climate analysis with this, and I think it's important that we keep it self-contained and to its sort of to the point, and we don't try to do too much. But the idea is that we can have it open source, so it would be relatively easy. For instance, if you want to embed graphics from this, or if you want to have this that is embedded in a web page where you also have a speckled graph, that could work together. If you want to pull data out, that is also something that we can look into. And have you looked to modify the EPW based on climate change models? Yes, that's exactly what we are looking into, because we are cognizant that it is a moving target. And I think it's very important that we try to, when we plan a building today, well, that is a building that's going to have a lifespan, hopefully for the next 50 or even 100 years. And we all know that in 100 years, the climate that this building will have to face might be significantly different. So we're looking at ways of implementing climate change model. So there are already a number of efforts to that. There is, for instance, a website called Weather Shift. Unfortunately, those are paywalled, but we think this is such an important and critical area that we should, when we try to design for zero carbon, I think this shouldn't be the privilege of the few, but we would like this to be something that everybody has easy access to. So this is what we are we're looking at. Is there any plans to provide modified EPW to an urban heat island weather file? Not yet. I think that would be as well the next step. I think that one has provides potentially even more challenges than the future weather files, because there are for creating the future weather file, we have to process a huge amount of data, but the data source is quite well established, because we can look at the climate models that the IPCC is using. So that and those as well are published and publicly available. You just need to have a very big hard drive, because we're talking about several terabytes. But I think that for the urban heat island, at the moment, we are not is not in our immediate plans. It's something certainly that we're interested into looking into. And if anybody has thoughts, ideas, or wants to help us contribute to that, be very happy for you to get in touch, and I'll be very happy to talk about this. Okay, let's see if there is any other question in the chat or in the Q&A, or otherwise I think we are pretty much on the dot with our schedule, even if we started a few minutes later. Thank you. Okay, then thank you everybody, and I'll be hanging around as well in the networking, and I'm curious to listen to all the other beautiful presentation of the other speakers. So hopefully if there is any other question, or if you're interested in helping and contributing, please reach out. Thank you. Bye.